In this video, we'll look at the naming of binary compounds type 3. And for type 3 binary compounds, we'll concentrate on binary covalent compounds. Binary covalent compounds. Binary covalent compounds. So what are these covalent compounds? So you know that covalent compounds are simply those compounds formed from non-metals. When non-metals are involved in the sharing of electrons, they form what we call covalent compounds. So these binary covalent compounds simply deal with what? Two non-metals. So they are combined from two non-metals. So how do we name such compounds combined from two non-metals? What rules should we follow? Okay, so let's look at the rules that should be followed. So rules number 1. Okay, so the first rule, you should know that the first element in the formula is named first. So first element is named first. First element is named what? First. So the first element in the formula is named first using the full name of the element. The first element is sulfur. You should use the full name of the element, sulfur, like that. That's what it means. The first element is nitrogen. The full name of the element should be used. Okay. Then for the second element, that's number 2. Okay. So we're saying that the second element is named as if it were an ion. So you name the second element as an ion. So for the second element, you name it as if it were an ion, and that ion will be what? An ion, since we are dealing with non-metals. So the second element should be named as what? An anion. Okay. For example, if we have sulfur being the first element, it will be sulfur just like that. Then if you have oxygen appearing as the second element, meaning it will be an oxide. Instead of saying oxygen, you use oxide. Okay. If you have chlorine appearing as the last element, it will be chloride. That's what we are talking about. Otherwise, for the first element, you use the full name. Okay. Let's talk about other rules. So number 3. So the prefixes are used. So we use prefixes. So these prefixes are actually used to denote the number of atoms present. We use prefixes to denote the number of atoms present. For example, if we have CO2, we have 2 oxygen atoms there, and it's the last element, meaning use what? Oxide, right? Therefore, no wonder this one is carbon dioxide. Carbon dioxide. For di meaning 2. Then let's look at some more prefixes. So prefix and the number indicated. Okay. So mono, if we say mono, we are referring to what? Of course we know it's 1, right? Then di, we are referring to it's 2. Then tri, we are referring to what? That's 3. Tetra, we are referring to 4. Then penta, that's what? 5. Okay. Then hexa, that's what? That's 6. Then hepta, so hepta, that's 7, hepta or septa 7, then octa that's 8, then nona that's 9, deca that's for 10. So these are the prefixes that you should know, and we'll be using them to name binary covalent compounds. Okay, then let's look at rule number 4. So rule number 3 is for using prefixes. Then rule number 4, we are saying the prefix mono is never used for naming the first element. For example, carbon monoxide. So the name of this compound, that's carbon monoxide. So we have used mono before oxygen because we just have one atom of oxygen there, or one element of oxygen. Then what about for carbon? Of course, even for carbon we have one atom like that. But why didn't we say monocarbon monoxide? No, you don't do that for the first element. So for the first element, you never use mono unless it's 2 or more. That's when you use di. So you don't have to say mono carbon monoxide. No, that's against the rules. It's against the rules. Just say carbon monoxide. Unless we had 2 there, I would have said dicarbon monoxide. Otherwise, that is very important to take note of. For the second element, you can start from mono all the way, and so on. Yeah. Okay. So proceeding, let's try to look at some more examples. So let's say I've been given this compound N2O. What is the name of that compound? Applying the same rules. Okay, so N2O, we know this is nitrogen and this is oxygen. So we have 2 atoms of nitrogen. Therefore, using dinitrogen. Then 1 atom of oxygen. So dinitrogen what? Monoxide. Dinitrogen monoxide. That is the systematic name of that compound. Then it has a common name called nitrous oxide. This one is commonly known as nitrous oxide. That is its common name. N2O, that's nitrous oxide. Then what about, what if you are given NO? What is the name of that compound? Systematic name. So this is simply nitrogen monoxide. Nitrogen monoxide. And the common name of this one is nitric oxide. That is its common name. Nitric oxide. Okay. And that is the systematic name, nitrogen monoxide. What about this one, NO2? So for NO2, so for nitrogen atom, we have 1. We won't use mono. Instead, we just start with nitrogen. So nitrogen. Then we have 2 atoms of oxygen. So it will be what? Dioxide. Nitrogen dioxide. Okay. Then what about if we have N2O3? What will be the name of this compound? So we have 2 atoms of nitrogen, we use di, then 3 atoms of oxygen, we use tri. So it will be dinitrogen, so dinitrogen trioxide, like that. Then what if you have this compound N2O4? 2 nitrogen atoms, so use di, 4, so use tetra. So the name of the compound is what? Dinitrogen tetroxide. Dinitrogen tetroxide. Okay. What about this one? N2O5. This one will be what? We have 2 atoms of nitrogen, so it's di. 5 atoms of oxygen, that's what? Penta. Okay, so the name will be what? Dinitrogen pentoxide. Dinitrogen pentoxide. Okay. Then here you should take note of something so that, let me even call it row number what? So far we have talked about how many rows is it? 4? Yeah. Let me call it row number 5. Okay. So for row number 5, you should know that we often drop the final O or A. We drop the final O or A of the prefix when the element begins with a vowel. When the element begins with what? A, E, O, and O. When an element begins with a vowel, we drop the final A or O of the prefix. For example, these same ones we have already named, the same examples. Okay, so let's start with this one, N2O5. N2O5. So we have said this is dinitrogen pentoxide. Okay, then for for 5, we know that the prefix is what? Penta. We said the prefix is penta. So why didn't we say dinitrogen penta oxide? Why didn't we say dinitrogen penta oxide? So to avoid awkward names, we often drop this final A when the element that is coming starts with a vowel. So O is in this group of vowels. Therefore, we drop this final A, and the name simply remains what? Pentoxide. Like that. That's what you do. Same applies for this one. Same applies if we get back to this. This is dinitrogen monoxide. So mono for oxygen, that's 1. So 1, that's mono. Okay, mono. So when coming up with the name of this one, why didn't we say dinitrogen mono for the prefix 1? Then we also say oxide for oxygen. Okay, so to avoid such awkward names, we get rid of the final O of this mono and just remain with monoxide. Okay. That's what we do. Then even for that one, tetroxide, where is it? Yeah, this one. Dinitrogen. Is it? It's this one. Dinitrogen tetroxide. We know that 4, that's for tetra. And we have 4 tetra there. Yes. Then this side, the final A was dropped. We simply said tetroxide instead of saying tetra oxide. So these are just some simple rules we follow. Get rid of that A and it will be tetroxide. If the element that follows starts with a vowel, you get rid of the final A or O of the prefix. So we often do that to avoid awkward names. That's what we often do. Okay, hope you have gotten the concept there. Then another thing, you should know that some compounds actually we use common names instead of systematic names. For some compounds, we just concentrate on using the common names and not systematic names. So the systematic names, you find that they are even never used. For example, H2O, what compound is that? We know that is water. But why not saying dinitrogen monoxide? So this is dinitrogen monoxide, which is simply water. Dinitrogen monoxide, which is simply water. So water is the common name and the systematic name dinitrogen monoxide. What about this one? NH3. So NH3, we know this is what? This is ammonia, right? That's ammonia. So that's its common name. But the systematic name, that's nitrogen trihydride. Nitrogen trihydride from hydrogen. Okay. Then what about this one? H2O2. What compound is this? You know that this is what? Hydrogen peroxide. That is the common name. Hydrogen peroxide. Hydrogen peroxide. Okay. That is the common name. But why don't we just say dihydrogen dioxide? That is the systematic name. Otherwise, for some compounds like this, we actually just use the common names instead of systematic names. Hope you get note of that. Then let me give you just some more examples. Okay. Let's say name the following compounds. Give the systematic names to the following compounds: PCl5. So the first thing, identify the elements used. P, that's phosphorus. Cl, that's chlorine. Then one atom of P, phosphorus. Remember, for the first element, you don't use mono, so you simply write phosphorus. Phosphorus. Then Cl5, this is chlorine, penta. So it's phosphorus, penta, oxide. Is it pentoxide? No. Let me write this again. I don't know why I'm using oxygen. Phosphorus, that's penta. So chlorine will change to what? Chloride, pentachloride. Phosphorus, pentachloride. Okay. So as you can see, we have not dropped the final A because the C doesn't belong to vowels. Okay. Then B, let's say you have been given PCl3. What is the name of the compound? So this is phosphorus, that's chlorine. 3 atoms of chlorine, we use tri. So this is simply phosphorus trichloride. That's it. Okay. What about this one? Let's say you have SO2. What is the name of that compound? So we know that is sulfur. So you write sulfur. Then this is oxygen. So dioxide. Sulfur dioxide. Okay. Then what about this one? P2O5. What is the name of the compound? So this is phosphorus, that is oxygen. 2 atoms of oxygen. 2 atoms of phosphorus. It will be what? Diphosphorus. Then pentoxide, not pentaoxide. So pentoxide. Diphosphorus pentoxide. Okay. Then let's also look at this one, SF6. This one, what is its name? So this is sulfur. sulfur, then 6 atoms of what? This is fluorine, so use fluoride. Sulfur, then 6, that's hexa, so sulfur hexa fluoride. Sulfur hexa fluoride. Okay. Sulfur hexa fluoride. So this is how you come up with the systematic name, applying those rules. Then what about writing the formula? Let's say you have to write the formula given a systematic name. The first one, let's say I've been given sulfur hexafluoride. So you check sulfur, this is simply S, then fluoride from what? Fluorine. Then hexa, that's 6. So SF6. That's sulfur hexafluoride. What about this one? Let's say sulfur trioxide. Sulfur trioxide. So first element sulfur, which is just S, then oxide, this is from oxygen, tri, 3 oxygen atoms, so SO3, sulfur trioxide. Okay, then what about this one? Carbon dioxide. So carbon, first element, you write C. Oxide, so this is O, then this is di for 2, carbon dioxide. What about this one? Diphosphorus pentasulfide. Disulfurous pentasulfide. So phosphorus, that's P, then there is this prefix di, meaning 2. Okay, then sulfide from sulfur, S, then penta, that's 5. Phosphorus, diphosphorus penta sulfide. Okay, so this is it. This is how you name binary covalent compounds. Okay, so that's it for this lesson. I hope you have understood. See you in the next lesson.